Good morning, student. Welcome to the class. I hope you are ready to explore one of the most exciting and practical topic in electromagnetism, that is electromagnetic induction. We can say in short EMI. So before we start, let me quickly introduce myself. So my name is Rahmatullah and I hold a postgraduate degree from Aligarh Muslim University, which is one of the most famous university in India. So now if I talk about like my teaching experience, so I have been teaching physics at senior level over more than 5 years, and I have worked across different curricula, including CBSE, class 11, 12, JE, and IGCSE, Cambridge, and also there is another curricula, IB diploma program. So now let's get into the topic, our electromagnetic induction. So basically, I have divided this topic, electromagnetic induction, in six sections so that we can understand easily the each perspective of electromagnetic induction. So first, in the section one, we are going to study about what is basically electromagnetic induction. And in the section second, the Faraday's experiment, basically the Michael Faraday given this electromagnetic phenomena, or we can say the principle. So we are going to study the experiment, okay? In the different way, what is they have taken to explore the electromagnetic induction. And in the section third, we are going to study about the Faraday's law, basically what they have drawn from the experiment. In section 4, we are going to study about Lenz law, and then in the section 5, we are going to study the application in real life. What is the application basically in real life? What we have the use of the electromagnetic induction principle in our real life, okay, in the electrical devices. And in the section 6, we are going to study about like quick questions, some related to our previous study, what we have get to know from our previous study in section 1, 2, 3, and 4, 5. Okay, so quick question will be totally memory based, so you can answer it easily without any hesitation. And I will tell you also the answer if you don't know. So let's get one by one section. In the first section, we will understand the electromagnetic induction with the help of diagram. So for this, we need to have a bar magnet and a coil of current conducting material. To understand the electromagnetic induction, I have taken a bar magnet. This side is south pole and this side is north pole. So as you can see, the magnetic field line is origin from North Pole and terminated on South Pole. I have taken a conducting coil. This is a conducting coil made up of some conducting material. When I am coming closer to this bar magnet toward the coil, there will be production of induced current in this coil. And when I have taken away this magnet taken away from the coil, then there will be also induced current in this coil. But if I take this bar magnet at some distance, just fixed, then there will be no induced current, but there will be associated with the magnetic field line. This field line will be there in this coil, but there will be no induced current. So we can say that induced current only produced when there will be change in field line, or we can say magnetic field lines, or we can say the magnetic field. So when I have taken this closer to this field, this ring, or we can say this coil, there will be more number of field lines will be associated with this coil. So there will be induced current. And when we goes away from this coil, then there will be lesser number of magnetic field line will associated with this coil. So in both the cases, magnetic field line will change it, and this situation there will be induced current in this coil. So this phenomena was discovered by Michael Faraday, one of the scientists, in 1831, and he found the magnetic field around the coil change, it induced the current. In section 2, we will get to know the Faraday's experiment with the help of diagram setup. setup we can see there. I have a coil. This is a coil, conducting coil, and I have connected this both terminal, both the in with the galvanometer. Basically, galvanometer is a current detecting device or electrical device, you can say, and this is a bar magnet. And these are the field lines, as you can see. This bar magnet coming closer to this coil. There will be more number of magnetic field lines associated with this coil. So there will be deflection of this galvanometer due to the current. So he took a coil of wire and connected to the galvanometer like this setup and then moved bar magnet toward and away from the coil. He's seen there will be detection of current. So I have taken the different situation. So the first situation you can see there in A, no deflection in the galvanometer when there is no motion in the bar magnet. Okay. So bar magnet is just fixed close to the coil. So there will be no, basically flux is associated, but the flux is not changing with this coil. That's why. And in the situation of B, the right deflection, there is a right deflection of this needle of galvanometer. Why? Because I just have taken this bar magnet with V speed toward the coil. There will be change in the magnetic flux. So that's why there is induced current in this coil setup. And so the current is detected by galvanometer. And similarly, I just take in the bar magnet inside the coil. There will be magnetic field, but there will be no change in magnetic field line. Okay. So that's why there is no current. So there is no deflection in the galvanometer. Now coming to the other situation. So this is the situation I can say D, left deflection. Why this left deflection? Because what happens here, I just taken away this bar magnet. So there will be lesser number of magnetic field lines. That's why the current is set up in such a way that there will be magnetic, this bar magnet, they just wanted to near the support. So the direction of induced current in the coil will totally depend on the movement of this bar magnet. So this time the current is set up in this direction. And now what happened here, this bar magnet, I am coming closer to this coil with V2 speed, and V2 speed is more than V1 speed. So what happened? There will be more deflection. So depend upon the velocity. And in this situation, left deflection is there. Why? Because they change the pole. Okay. That was north and that is south. So the direction of the current will change. We have seen all six methods we have used in the experiment of Faraday's. In conclusion, we can say induced current only produced if there is change in the magnetic flux associated with the conducting coil. So in this third section, we will understand the Faraday's law. So basically Faraday given two laws. In the first law, they said when will the induced current will set up in the coil. Basically, in which situation induced current will generate or you can say produced in the coil. And in the second law, the magnitude of induced EMF produced will be given. Here, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. Now let's know it mathematically. Faraday's second law formula, you can say EMF. This is electromotive force is equal to minus of d phi by dt. D phi by dt, the phi is magnetic flux and d phi by dt is the rate of change of flux. That is magnetic flux, of course. So in section 4, Lenz law gives the direction of induced current set up in the coil. So basically, when we have a coil in this hand and we have a bar magnet, it has north and south pole. Let's say we are coming closer north pole to this coil, then what will be the direction of induced current in this coil? And if we closer the south pole, then what will be the direction of induced current in this coil? So this law gives the induced current direction in the coil. Now coming to this application in real life. So we have electric generator. In power plant, electric generator is used. There is also the magnetic field and inside magnetic field, there is a coil which moves. And in the transformer also, electromagnetic induction principle is used here. Also, there is a induction cooktop and we have wireless charging mobile. There is also induction. Okay, quick question. So let's say you have taken a coil and a voltmeter and a bar magnet. So you have connected one terminal of a voltmeter to one end of the coil and other terminal of the voltmeter connected to other side. And you just have placed the bar magnet inside the coil. Then what would happen? Like we can see in this diagram. So let me know your answer, your thoughts. What would be there in the voltmeter reading? Now come to the conclusion part. So basically, electromagnetic induction is creating electricity from changing magnetic field, and the Faraday's law basically when the electricity or we can say induced current produced, and also the magnitude of induced EMF, and the Lenz law obviously in the direction of induced current. And if you talk about like application part, so we use in power plant to produce the electricity, and also in the smartphone to charge wirelessly. So these are the condition of electromagnetic induction. I hope you understand the concept of this topic, electromagnetic induction. Okay, thank you. See you in the next class.